I saw. Good morning to Prashant Reddy.
Good morning, sir.
Good morning. Welcome. Today we will discuss port forwarding. Hope I will start the class and eventually others will join. Is it audible to you?
Yes, sir.
Hello?
Yes, sir. Audible, sir.
Okay, audible. Fine. So, forwarding is an very important topic in the third in the module 5 port forwarding. As per the previous question papers, they will ask what is port forwarding, and however, it is better to concentrate on other important topics which are likely to ask in the examination also. Today we will discuss what is port forwarding, why port forwarding is required, and what are the security aspects of port forwarding. Today, due to the advent of different technologies and adoption of information communication technologies, you'll get very good videos and very good material which explains what is port forwarding. But as per the syllabus, you will concentrate what is port forwarding today and possibility of asking certain associated questions with respect to the port forwarding. So, very first question: is how to forward ports on your router. So, friends, when you want to access your some programs which is not on your machines, you require port forwarding. Today, we won't do port forwarding manually because most of the routers will do automatically this functionality. Some applications will require you to manually forward a port to that application or device. Unfortunately, it's really simple to if you know where to look, right? So, very first question that comes to our mind is what is port forwarding? There are plenty of projects we have covered that use our computer as a server for other devices, maybe knowingly or unknowingly. But when you are inside your network, most things will work fine. But some apps, if you want to access them when you are outside your network, make things significantly higher. Let us start by taking a look at why that is, right? So, how your router handles requests and uses ports. That is what is very first we have to understand. Here's a map of a simple home network. The cloud icon, that's what I am going to show in the diagram in the next, will explains you here. There's a cloud icon, okay, represents the greater internet and your public or forward facing internet protocol IP address. This IP address represents your entire household from the outside world, like a street address in a way. The red address 192.1.168.1 is the router address within your network. The additional addresses all belong to the computer seen at the bottom of the image. If your public IP address is like a street address, think of the internal IP address like apartment numbers for that street address. Okay. So now coming to this, what we explained, right? The diagram raises an interesting question which you have not thought about before. How does all the information from the internet get to the right device inside the network? If you visit howtogeek.com on your laptop, how does it end upon your laptop and not your such desktop with the public facing IP address is the same for all devices. Okay, you'll get some more information. Okay, so this is the idea that we have to think, that we have to worry about. Okay, then the answer is thanks to the wonderful bit of routing magic known as network address translation. You have seen now what is network address translation. So this function occurs at the router level where the NAT network address translator acts like a traffic comp, directing the flow of network traffic through the router so that a single public IP address can be shared among all the devices behind the router. Because of the NAT, everyone in your household can request websites and other internet content simultaneously, and it will be delivered to the right device. So, network address translation is working behind. So, where do ports come into this process? Ports are an old but useful holdover from early days of network computing. Back in the day when computers could only run one application at a time, all you had to do was point one computer at another computer on the network to connect them as they would be running the same application. Once computers became sophisticated to run multiple applications, early computer scientists has to wrestle with the issue of ensuring applications connected to the right application. Thus, ports were born. This will tell you why ports were required. Friends, your postgraduate students, you know all these things very well, but still, as a matter of context, at this point of time, it is better to recall once again why ports were born. That's why I have just explained. Some ports have specific applications which are standard through the computing industry. You know that when you fetch a web page, for example, it uses the port 80. The receiving computer software knows that port 80 is used for serving HTTP documents. So it listens there and responds accordingly. If you send an HTTP request over a different port, say 143, web server won't recognize it because it is not listening there. Although something else might be like an IMAP email server, which traditionally uses that port. Other ports don't have pre-assigned users, and you can use them for whatever you want to avoid interfering with other standard avoiding applications. It is best to use larger numbers for these alternate configurations. Plex Media Server, for example, uses port 32,400. So you know that there are order of 65,000 port address or numbers are available. However, some of the port numbers are reserved that you cannot use and you should not use. For example, Minecraft servers use 25565. Both numbers that fall into this fair game territory. Each port can be used via either TCP or UDP. TCP, you know, transmission control protocol is what is used most commonly. UDP or user datagram protocol is less widely used in home applications with major exception BitTorrent. Depending on what is listening, it will be expecting requests to be made in either one or the other of these protocols. Friends, so you have to understand why you need to forward ports. Why you need to forward ports. So why exactly would you need to forward ports? While some applications take advantage of NAT to set their own ports and handle all the configuration for you, there are still plenty of applications that do not. You will need to give your router a helping hand when it comes to connecting services and applications. Therefore, we need to forward the ports. In the diagram that I am showing to you, which simple premise, you are say on your laptop somewhere in the world with an IP address of something, like for example 225.213 point or dot 7.32, and you want to connect your home network to access some files. If you simply plug your home address, that is 127.34.73.214, into whatever tool you are using, okay, and that tool does not take advantage of those advanced router features we just mentioned, you are out of luck. It won't know where to send your request, and nothing will happen. That's why you need to forward the port. It's shown here, right? So if you want to access from this is the cloud, you can say internet, and from your router you want to access many things. So then there is the problem. This is, by the way, is a great security feature. If somebody connects to your home network and they are not connected to a valid port, you want the connection to get rejected. That's why the firewall element of your router is doing its job, rejecting unwelcome requests. If the person knocking on your virtual door, however, is you, then the rejection is not so welcome, and we need to do a little tweaking, right? To solve the problem, you want to tell your router, hey, when I access you with this program, you will need to send it to this device at this point. With those instructions in place, your router will make sure you can access the right computer and application on your home network. So I hope with this detailed explanation, you have understood why the port forwarding is required. And this is actually as per the syllabus, I can say, but there are instances where, since you have studied Unix and Linux, they may ask you certain questions associated with the port forwarding, like SSH port forwarding. Discuss SSH port forwarding and its time. So that's why we discuss SSH port forwarding. SSH port forwarding is a method used for securing TCP/IP connections. The TCP/IP packets can be tunneled through a SSH. SSH stands for secure shell. Okay, so the TCP/IP packets can be tunneled through a SSH link, making the data obscure, thus protecting the link from attacks. SSH port forwarding can be also seen as a form of virtual private network. We'll discuss in the next class what is virtual private network. Now, please remember that SSH forwarding can also be seen logically as a form of virtual private network. There are types of port forwarding. There are actually two main types of port forwarding: local port forwarding and remote port forwarding. These are explained as follows. Very first, we will see what is local port forwarding. Suppose you are on a local network that restricts access to a site. Let us suppose example.com. To work around this, we could create a tunnel through a server that is not on our network and thus has example to example.com. The command we would use can be like this: on a Linux platform, SSH minus capital L 9090 :example.com :80 admin at server.com. The minus L is a flag. Here tells that local port forwarding is being used. So what the above command does is it forwards the data on local port 9090 to the server, which has access to example.com through a secure SSH connection. Note here that admin is a user on the server. Now you can visit example.com on your browser. So how it happens, this is shown here in the figure. User local port 9090, a tunnel is being established between the local machine and the remote port is the machine where example.com is being run. There is an admin in between. So please go through this, you'll completely understand the things. Okay, now let us see a second scenario. What is the second scenario? A second scenario would be a situation in which you want to access a service on the server which is open only on localhost for some security reasons. So then you have to do the following command: SSH minus L 9090 :localhost 3306 admin server.com. Make a note here that localhost in the command is from the perspective of the server. The server is running a MySQL service on port 3306 and it allows only local connections. So remote port forwarding. So far we have seen local port forwarding. Now we will see remote port forwarding. The command for remote forwarding is SSH minus R 9090 :example.com :80 admin at server.com minus R, or I can say hyphen R flag specifies that requests on remote server port 9090 should be forwarded to example.com, which is on the local network at port 80. Now, if you make a request to the server on port 9090, you would get a reply from example.com. Here is the figure that demonstrates the remote forwarding. Okay, so remote forwarding, this is the server and the user is here and example.com is here. This is the local network and this is the server on the remote. Okay, now what is port address translation? There may be a question: network address translation and port address translation. So we have to see what is port address translation. So as the heading itself shows, port address translation, in short, called as PAT, maps to private IPs. Maps to private IPs, internet address, right? Internet address. IPs. Fine. So in the beginning, very first, before understanding that, we should keep in mind that when we connect our laptops, our smartphones, our tablets, etc. to the home network, all get IP address, because IP address is important for making any communication. For the addressing purpose, address is required. We use IP address. This IP address, which is assigned to these devices, is not public IP address. Okay, these devices, whether it's a laptop, smartphone, tablets, whatever you are connecting to the home network, all will get IP address, but these IP addresses are not public IP addresses. Rather, they are private IP address. This home network is a local area network. Use of a private IP in home networks, then the private IP are not registered. Thus, it cannot be used to find a user uniquely over the internet. The public IP address, however, it is registered. You can use it to recognize a particular machine on the public network. The private IP are usually in the range 192.168 point or dot x and 10.x.x.x. These private IP are assigned by the routers to each device which is connected to the router. So here some detailed figure is shown. You can go through it at a later point of time, which is very simple. That is your exercise work, you do it. Okay, those are very simple also. I'm going actually in a way to the basic, very basic points. The main idea is to explain why the port, what is the port address translation or PAT. So when then how our device is connected to the internet is the private addresses assigned to them cannot be uniquely identified over the internet. This is where port address translation PAT comes into picture. These are also commonly known as network address translation. Overload comes into the picture. Okay, so that you have to understand. An important thing to keep in mind is that only our router which is connected to the internet is given a public IP. Thus, all devices in the LAN communicate with the internet using only one public IP. Necessity of private IPs in LAN to conserve the available IPv4 addresses. Each device in the home network is assigned a public address that we have to use. PAT. So port address translation. Okay, port address translation. So now is the actual thing. This solves the problem of how devices with a private IP address would connect to the internet using simple single public address which is assigned to the edge router. Let us quickly go through certain certain steps in private IP resolution. The step one: when a device in the private network wants to connect to a website, then it does all the steps as per the OSI model in the device itself. An IP packet is created and then gives the IP packet to the router present in the home network. The port address translation is implemented in the router. So now the IP packet received by the router has a private IP and a port number given by our computer. So now the router will substitute the private IP with the public IP of the router, and specific port is assigned to that connection of that device. Right? Now let us see the next step. An entry is created in the translational table mapping which private IP and port is mapped to which public IP and the port of the router. Thus, finally, the port field of the IP packet is replaced by the new port number assigned by the router. The packet is routed into the internet as per the networking rules. This is what happens, right? So you have to note that the entry in the translation table is made only first time when the connection is established between a specific host to other specific destination host. The destination IP and destination port are not changing. Replay IP packet by destination host. The destination host replies back, and in the reply IP packet, the destination IP address is the router public address and port number is the port number assigned by the router for that specific connection in that specific device. This is what happens. Now, the third and the last point is port security in computer network. Attackers' task is comparatively very easy when they can enter the network they want to attack. Ethernets are very much vulnerable to attack as the switch ports are open to use by default. Various attacks such as DOS, denial of service attack at layer 2, address spoofing can take place. If the administrator has control over the network, then obviously the network is safe. To take total control over the switch ports, user can use feature called port security. If somehow prevent an unauthorized user to use these ports, then the security will increase up to a great extent at layer 2. User can secure a port in 2 steps, limiting the number of MAC addresses to a single switch port, that is more than the limit. MAC addresses are learned from a single port, then appropriate action will be taken. If an unauthorized access is observed, the traffic should be discarded by using any of the options are more appropriate. Users should generate a log message so that unauthorized access can be easily observed. So these things should happen. Port security, switches learn MAC addresses when the frame is forwarded to a switch port. By using port security, user can limit the number of MAC addresses, as I have already discussed, that can be learned to a port, set static MAC addresses and set penalties for that port if it is used by an unauthorized user. Can be the another step that can be taken. User can either use restrict, shutdown or protect port security commands. Okay. The next is protect. How to protect? This mode drafts the packets with unknown source MAC address until you remove enough secure MAC addresses to drop below the maximum value. Restrict. This mode performs the same function as protect, that is drops packet until enough secure MAC addresses are removed to drop below the maximum value. In addition to this, it will generate a log message, increments the counter value, and will also send SNMP trap. SNMP stands for Simple Network Message Protocol. Shutdown. This mode is most preferred one compared to other modes, as it shut down the port immediately if unauthorized access is done. It will also generate a log increment counter value and send a SNMP trap. This port will remain in shutdown state and the administrator will perform no shutdown command. Sticky, this is not a violation mode. By using sticky command, user provides static MAC address security without typing the absolute MAC address. For example, if user provides a maximum limit of 2, then the first 2 MAC addresses learned on that port will be placed in running configuration. After the second learned MAC address, if a third user wants to access, then appropriate action will be taken according to the violation mode applied. The port security will work on access port only. That's the point now to remember. To enable port security, therefore, user first has to have an access port, identify a port and make it access port, make that access port ready for the implementation of port security. Friends, today we have discussed what is port forwarding, why we need to port forward, and what is PAT, what is NAT, and the different security modes or violations of the port forwarding. So, with the examples, leisurely go through it. I think you need a good time to understand this concept thoroughly. Go through it. I'll be sharing the PPTs for your reference. Also, I'll be uploading today's class onto the YouTube, and you can definitely make use of all the information that is shared. And before the test, I will discuss what are the different types of questions comes. Okay, thank you for patiently listening. Thank you one and all.